You could think of our entire understanding of the universe as this giant, unfolding map. For centuries, we've been on this incredible mission to chart everything, right? To draw the one, final, definitive map of all of reality. But here's the amazing part. Every single time we think we finally got it, that the map is complete, a new architect comes along and basically tells us we've been holding it upside down. So today, let's meet some of those architects.
So let's go way back, all the way to the ancient Greeks. They had this beautiful, almost poetic term for what they're after, topon. It literally just means the all. And it perfectly captures the scale of what they were trying to do, to understand everything, all the matter, all the space, the whole shebang. This wasn't just some academic exercise, it was this deep human desire to figure out our place in the cosmos.
And that very quest for the all, that's the engine that has driven some of the most brilliant people in history. And you can't just call them scientists. They were more like cartographers of reality, sketching out the very laws that govern why we're even here. They were the architects, building our view of the universe, one world-changing idea at a time.
Our first great mapmaker? Well, you've definitely heard of him, Isaac Newton. See, before Newton, the universe could feel pretty random, Chaotic, mysterious, maybe even governed by the whims of the gods. But Newton steps onto the scene and gives us a universe that makes sense. It's orderly, it's predictable. He gave us the map to a clockwork universe.
I mean, the guy's life was just this powerhouse of genius, right? But the real game changer was in 1687 when he published his masterpiece, the Principia Mathematica. This thing wasn't just another book. It was the rulebook for reality. It laid out the laws of motion, the law of universal gravitation. It created a framework so powerful, it would basically be science for the next 200 years.
And that is not just hype. As chemist William H. Cropper put it, Newton was probably the greatest creative genius physics had ever seen. But the truly mind-blowing part of his work was what it implied, that the universe was like a perfect, solvable machine. If you just knew where every particle was and how fast it was going, you could, in theory, predict the entire future of everything.
And for 2 whole centuries, that was it. That was the map. It was incredibly comforting, wasn't it? It was rational. The universe was this grand clock, just ticking away, following these beautiful, unbreakable laws. As far as anyone was concerned, the map was done. But, as we're about to see, maps can be very, very deceiving.
And then, along comes a young patent clerk in the 20th century named Albert Einstein. And he starts to see these little frayed edges on Newton's perfect map. He realizes that when you get close to the speed of light, that beautiful clockwork universe starts to fall apart. The map wasn't just missing a few details, it was fundamentally wrong. It was time to redraw the whole thing.
So here's the absolute heart of the difference, right? For Newton, gravity was this mysterious, invisible force, just pulling things together across empty space. Simple enough. But Einstein's idea, whoa, it was way more radical. He said there is no pull. Gravity is just the shape of the universe. Heavy objects like the sun literally bend and warp the fabric of space-time, and planets aren't being pulled. They're just rolling along the curves.
And this quote from physicist John Archibald Wheeler just nails it perfectly. It's this beautiful cosmic dance, right? Space-time, the stage, tells matter, the actors, how to move. And in return, the actors tell the stage how to curve and bend. It's honestly one of the most elegant and profound ideas in all of human thought. And the fallout from this new map was, it was mind-bending. Suddenly, time wasn't some constant thing ticking everywhere at once. It could actually slow down. Matter and energy were just 2 sides of the same coin, linked by that iconic equation, E=mc². He even predicted these tiny little ripples in space-time itself, gravitational waves, that took us a full century to finally find. Einstein didn't just add a new continent to the map. He revealed we were living on a sphere instead of a flat piece of paper.
So who was the person behind this seismic shift in reality? J. Robert Oppenheimer put it beautifully. He said Einstein had this wonderful purity that was both childlike and profoundly stubborn. And really, it took that exact combination, that stubborn refusal to accept the old map, to see the universe in a totally new light.
But here's the crazy part. At the exact same time that Einstein was redrawing the map of the cosmos, a whole other group of explorers were drilling down into the fabric of matter itself. And the things they found in those hidden territories, they were stranger than anyone, even Einstein, could have possibly imagined. Welcome to the quantum enigma.
It all really kicked off with the electron. See, in that old Newtonian clockwork world, an electron should be like a tiny planet zipping around a nucleus in a nice, neat orbit. But it wasn't. It acted like a particle sometimes and a wave at other times. And you could never say the electron is here. The best you could do was point to a fuzzy area and say, well, it's probably somewhere in this cloud of probability. And that one idea just shattered the whole clockwork universe. Think about it. If you can't even know for sure where one single electron is, then that old dream of a perfectly predictable reality is just gone. It meant that at the most fundamental level, the universe wasn't a machine at all. It was a cosmic casino, running on probability and pure chance.
This led to one of the most epic intellectual showdowns in history. On one side, you had Niels Bohr, who basically said, yep, it's weird, but that's just how reality is. On the other side was Einstein. And here's the irony. The great revolutionary became a conservative. He just could not accept that God plays dice with the universe. He was convinced that this randomness was a sign our map was incomplete, that there had to be a deeper layer of reality we just hadn't found yet.
The thing that really got under his skin, the thing he called spooky action at a distance, was quantum entanglement. This idea suggested that you could link two particles, then send them to opposite ends of the galaxy. And the moment you measure one, the other one would instantly react. To Einstein, this was nuts. It seemed to violate the ultimate speed limit of the universe, the speed of light.
I mean, this quantum world was so utterly bizarre, so deeply counterintuitive, that physicists almost had to joke about it just to keep going. There's a great line about Paul Dirac, one of the pioneers of quantum theory. A colleague joked, "There is no God, and Paul Dirac is his prophet." It just perfectly captures the mind-bending, almost religious weirdness of this new map.
So, where does that leave us? We've got two incredible and incredibly successful maps from physics. One for the very big, one for the very small. And they don't quite line up. Well, this is where something like metaphysics comes in. It's a branch of philosophy that takes a step back and questions the very idea of the map itself. So while a physicist uses the law of causation, a metaphysician asks, wait a minute, what even is causation? They're not running experiments, they're stress testing the absolute foundations of our thinking.
And then, what about the maps of our inner world, of the human experience? I mean, think about a great storyteller like Stephen King. Isn't he a map maker too? As Joyce Carol Oates says here, he's charting the terrain of the human heart, our fears, our secrets. He's not using equations, he's using stories to make sense of who we are.
And this is what's so cool. When you look closely, you see these different map makers are all wrestling with the exact same deep mysteries. Take time, for example. For Newton, it's a river, flowing the same for everyone. For Einstein, it's a fabric that can stretch and bend. A philosopher asks if it's even real. And a novelist like King explores it as the source of memory and regret. See? They're all trying to chart the same unknown territory, just with different tools.
Which brings us right back to today. We've gone from this nice, tidy clockwork machine to a warped, relativistic universe, all the way down to a bizarre, probabilistic quantum casino. And we've seen that the tools for understanding it all are as different as the questions we ask. The map is so far from finished. The quest is absolutely still on.
Really, the story of science and philosophy and even art, it's the story of this constant redrawing of the map.
Each generation of thinkers inherits a map from the last one, and the bravest among them dare to say, what if this border is wrong? They explore the uncharted lands, and they sketch out a new, more detailed, and almost always much, much stranger picture of the world. So that leaves us with one last huge thought. Our entire map of reality has been torn up and completely redrawn not just once, but multiple times. We went from a clockwork machine to warped space-time to a quantum casino. We know for a fact that the map we have right now is not the final one. The only question is, what's the next one going to look like? And who's going to be the architect that draws it?